Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Razani bin Ahmad Azri. I would like to present my final year project, which is modeling and simulation of battery pack system for e-bike. For the introduction, this battery pack system will provide the electrical supply to the electric vehicle. But the main concern with the battery pack will be the energy storage system, which involves several issues. The problem statement for this project, the size and arrangement of the battery is crucial due to the limitation of the battery inside the motorcycle. And next, the rapid increment of the temperature during the end of the charging process could lead to abnormal events. The electrical unbalance can occur due to the different state of charge. Safety is one of the key elements in the battery pack system design. So the main objective will be to design and simulate a model represent the battery pack system in e-bike. And next, to estimate the size and arrangement of the battery cell in the e-bike. Furthermore, to analyze the temperature profile for the battery pack system. And lastly, the main objective will be to design and stimulate a controller that able to monitor the cells, reduce the temperature, balance the circuit, and protect the system. So this is a methodology for the project. First, this is a broad diagram for overview of the system, which is the battery pack system will provide the power to the power traction motor from the DC chopper to the wheel, and with the help with the battery pack controller to the battery pack system. Okay, for the vehicle parameter, as we know that the weight of the motor will be 100 kilo. Average weight of the person will be 70 to 80 kilo. The estimation weight for two rider is 150 kilo. So the total assumption weight will be 250 kilo. So the average of the motor will be 80 kilometer per hour. And this is the space dimension that have been measured for the motor, electrical motor in the lab. So this is the motor in the faculty lab. Okay, for the power traction motor parameter, the specification, the power will be 5 kilowatt, and this voltage is normal operating will be 48 watt. For the nominal current will be 40 ampere, and the speed will be 720 RPM. The motor torque will be 70 Newton meter. 17 Newton meter. So this is the motor for the final year project, and the battery that I use is lithium ion LG 18650, and the rated capacity will be 3 ampere hour, and the nominal voltage will be 3.6 volt, and the diameter will be 18 millimeter, and the height will be 65 millimeter. So the total assumption for the number of cells will be, for the series we have 13 cells due to 48 volt, and for the parallel we need the 60 ampere hour. So we will need 20 parallel. So the total number of battery cell will be 260 cells, and this is the dimension for the each cell. Okay, next method will be the battery pack controller. Battery pack controller has two functions. Firstly, to monitor the voltage, the current, and the temperature. And the second one will be control for cooling to reduce the temperature of the battery, and to balance out the distribution between the cell due to the different state of charge. And lastly, to power cut off by the relay for the protection. Okay, this is the operation. As you can see here, the cooling system, we have the temperature sensor detect the temperature at the battery pack system, and then goes to the Arduino. Arduino will process the data, and if the data higher than 35 degrees, it will turn on the fan. And this is the balance circuit. The charging unit goes to the current sensor, and the current sensor will pass the input to the Arduino. Arduino will process it until it become overcurrent or not. If overcurrent, it goes to the relay to cut off the power supply. If not, it goes to the balance circuit, and the balance circuit will distribute all the current evenly among the cells. Okay, this is the dimension that I have done during in the Alta simulation. As you can see here, the dimension is really packed inside the motorcycle space, but it fits in the motorcycle space. Okay, for the temperature profile, as you can see in the picture left side, the inner parts of the pack experience a temperature higher than outer part. So it means that inner part it will be could be lead to the abnormal events. Okay, this is the battery pack controller. As you can see, this is the battery pack system. And we goes to the balance board. This balance board will function to balance all the distribution of the current so that the current will charge all the battery evenly. And we goes to the microcontroller, which is the brain of the system. And this is a relay protection circuit which protect all the components here. And this is the temperature sensor for the cooling fan. So the temperature sensor will detect the high temperature so that it will process and turn on the cooling fan. Okay, this is the result. As you can see, 35 degree is not turned on the fan yet, but if the temperature is 36, it will turn the fan speed 10%. So if the temperature increase, the fan speed also increase. So it will reduce all the temperature inside the battery pack cell. Okay, as the conclusion, a model represents as the battery pack system in the e-bike as we created in the simulation. The size arrangement has been done, which is fit inside the motorcycle space, and the temperature profile found out is in the part is higher than the outer part, and the controller able to monitor the cell, reduce the temperature, and balance the circuit, also, and lastly protect the system. I think that's all for me. Thank you very much.